This is problem 9 from chapter 24. And what we're going to do here is demonstrate a two-sample hypotheses test and then follow up with a confidence interval. Now, hopefully you've read the problem and you can see that what we have is a teacher that's using two different techniques to teach students how to read. And she's hoping that the new method is better than what we're going to call a control or the traditional method. Okay, that we'll consider that the control. Okay, so if we think about the test, really, what's the objective? So they give you the scores. Do these results suggest that the new activities are better? Okay, are better. So it's not a two-tail, it's a one-tail. Okay, so I've written the hypothesis statements here. The mean reading comprehension score of students who learn by the new method is the same as the mean reading score by students who learn with the traditional method. Okay, and in here we say the same thing, but we say greater than. Okay, well, other than that. So we have to have some mathematical notation. So instead of P, remember we're not doing proportions now, we're going to say the mean population of the new method minus the mean population of the control or traditional, either way, is 0. And then the difference, in this case, the scores, well, we want the scores to be higher for the new method, so we're going to say greater than 0. So those are our hypotheses tests. Now we can go a little bit further. When we look at the conditions, we want to make sure that the two groups are independent. So it seems it's reasonable to say that the scores, the reading scores of students in one class aren't going to affect the reading scores of students in the other class. Okay, and it does say that they were randomly assigned. It mentions it up there. If you read it, you can see that they were randomly assigned to the classes. So we have a controlled experiment and nearly normal conditions. So now we have a little bit of work to do. So what I suggest you do is, quickly as possible, put the data into L1 for the new method and the data into L2 for the old method. And if you just to review how to read a stem leaf, this would be 24 and then 33 and then 43 and 43 and 43 and 46 and 49 and then 52 and so on. Okay, for L2 we start at 10, 17, 20, 26, 28, 33 and so on. Okay, so we want to get these as quickly as possible into L1 and L2, and then you're going to want to say second button, and then you do the stat plot, and you're going to have to do one at a time. So let's check my calculator. I guess I should have done this ahead of time, so I apologize, but my calculator has data from I think it's the second one. Let me check. Yeah, L2. So let me show you what I have for L2. I'm just going to sketch it. That's all you have to do for these histograms. So I'm going to start at 20. I did zoom 9, but then I adjusted it. So no, actually I start at 0 and I increment by 20. So I go 20, and there I have 2, and then I go to 40, and I have 6, so something like that, 40, and then I go to 60, and then that goes up to 11, So again, I'm just going to sketch it. And then 2 to 80, and then 1. Okay, so that's for L2. Say the bin size. Well, I don't really have to say the bin size. It's there. It's apparent because I labeled it. And then this is the data from the control. L2. Alright, so now let's look at L1. So I got to shift gears just a little bit. So I do zoom 9, and it's interesting graph. I also want to check some things. So zoom 9, and it looks like from the window, looks like I could start at 20. That's what I remember. Looks like I can start at 20. So I'm going to adjust, and I'm going to increment by 10 and go out to about 100 and change my Y to 10. So what I'm changing right now are the window functions. Okay, and then I hit this. So you should have something, if you start at 20 and go by 10s, 30, 40, 50, 60, 70, I get 1, and then I get 1 again, and then I have 5, so something like that, and then I go over to 7, so a little bit higher, and then down to 3, and then back to 1. Okay, so you should label it. This is the new method, and this is data in L1. You don't have to say that, but the histograms of the scores are unimodal and symmetric, or nearly unimodal and symmetric. So now the conditions are met. So I didn't leave a lot of room here, but I'll just say, since the conditions are met, we will proceed with a 2-proportion t-test. Oh, did I say 2-proportion? Look at, you see the habit that we get into? It's a 2-sample t-test of the difference in means. And say something like using students' T model with how many degrees of freedom? Well, we don't know. So I'm going to put that in and just leave it blank. Okay, so now we're all set. So what we want to do now is use the calculator commands. Okay, so if you can go to stat, test, and select number 4, a 2-sample t-test. Okay, and we go in, and I believe, let me just do that real quick, I believe the option that I blanked out is data. It's going to say data right here. So because you have data. You don't have summary stats. You have data. Select data and put in L1 and L2. And remember here, this is whatever you put in for the alternative hypotheses. And so for the alternative hypotheses is right here, it's greater than 0. So we're going to put that in right here. We don't pool, and then just hit calculate. And you get all the data you need right here. We get our t-value, p-value, all this stuff. Okay? So now you just all you want to do is really document these computations. This is enough right now to write your conclusion, but for the AP test you need to have documentation. So what we're going to do is say we want the observed value or difference. Let's use that. Is going to be x bar of n minus x bar of the control, and we can just pull that data off here. This is going to be 51.7222 minus 41.8181, something like that, and we get 9.9040. Okay, so that's our observed value. Now we need a standard error for our model. We need a standard deviation, but we can't find one. So we'll approximate the standard error of the difference. And there we're just going to take the standard deviation right here, 11.706 divided by the sample size, 18, and this is squared, by the way, and then we have 16.598, I'm going to round, divided by squared, divided by 22. And that has to be done manually. The computer doesn't do it for you. So I'm going to clear, and I'm going to say second square root, and just type it in just the way it is. 11.706, hit the squared button, then divide by 18, plus 16.598 squared divided by 22, and then I hit enter. Okay, so I get 4.487. So my t-value is going to be my observed value, 9.9040, minus the hypothesized difference, which is 0. Okay, and then we're going to divide by this. And let me just check. 9.9040 divided by 4.487 is 2.207, and there it is, right there. Okay, so our p-value is the probability of the difference being greater than 9.9040 if HO is true, and that's equal to the probability of t greater than 2.207. So that we could say T is CDF. Okay, but we really don't have to do that, do we? Because we've got it right here. The p-value is 0.01676. Okay, so we don't have to go that whole route, although we do need to document the degrees of freedom. So the best thing to do there is pick it up. It's 37.2 276. So make sure you've documented the degrees of freedom somewhere. Okay, now we need to draw a model, and I'm going to cheat again. I'm going to use my calculator. Let's see if I can, maybe I can just do, I may have it, yeah, there it is. Okay, so if you go back to the calculator function and repeat this, all the data will be in, but instead of saying calculate, say, I think it's plot. Stat test for, scroll down, oh, it's draw, my bad. Yeah, just say draw. Right there, and you'll get this. Okay, so you've documented everything. So since the conditions are satisfied and we've done everything correctly, let's say that since the p-value is low, we reject HO. There is evidence to suggest, can't spell, that students taught with the new reading method have a higher mean reading score. Something to that effect. Okay, so last thing is we want to compute a confidence interval. So let's see if we can do this. So the conditions are met. The conditions are already been satisfied. So the conditions for confidence interval are met. So we are going to start with an estimate plus or minus the margin of error. Okay, so here the estimate is going to be x bar n minus x bar c plus or minus t star df, and then the standard error of x bar n minus x bar c. Okay, so this is going to be, what was it, 9 point something. 9.9040 plus or minus, and this was 4.4 something. What was it? 4.487. So what is T with this many degrees of freedom? Okay, I'm trying to think, what did I do for this? Okay, so I get 2.026. So what we'd want to do here is, what did they ask us to do for the confidence interval? I forget what we were asked for. So that if I'm assuming I'm using a 95%. So if that's the case, then we would say T star of 37 point, what is it? 37.276 equals inverse T of 0.025 of 37.276. Okay, so I just want to check that myself. So second distribute inverse t of 0.025, comma 37.276. Yeah, 2026. Exactly. Okay, so I just wanted to confirm. This pen is not fun. 2.026. Okay, so if we do that, we get a confidence interval of 0.8129 to 18.9951. And again, you could use the calculator function. You just go back to stat test, and this time select the calculator function, and it will compute that for you, but you have to document this stuff. Okay, so we are 95% confident that the mean reading comprehension score of students who learn by the new method is, I kind of switched those. Well, no, is 0.8129 to 18.9951 higher than what? Than the mean scores from the traditional method. Okay, so sorry for the long video, but that's how you do this problem. There's some different ways to go about it, so I'm just going to kind of, if you wanted to just go straight to the end. So it starts here, and you can kind of just see what I did in the steps, how I incorporate calculator functions and document it. So you should be able to do a better job than I have done. Okay, good luck.